Hello, everyone, and welcome back to the third episode of Old Gen Tutorial. It's Sharif from Rebel Technology, and before we move on, we'd really like to thank for everyone who's watching this. I hope you can learn a little bit from what we're putting out, and we try to do this as often as possible, so keep tuned in. So before we get going, I'd like to apologize because last episode I've made a quite big mistake. It was late night, my brain was not fully functioning. So what happened was I accidentally connected wet signal after the feedback control, and really that should be before the feedback control. So let's grab this connection and then put it straight out of the low pass filter instead of the level of feedback. This way you can actually separate the feedback amount and your delay level, because your delay level is already controlled via Control D, and that's your dry wet. So my apologies. So now we fix this, let's move on to the actual episode of this tutorial. And what we're going to do today is we're going to add a tap tempo function. So your delay actually understands your tempo. That's exciting, right? So instead of making everything from scratch, I mean, we can, and I hope you can after this tutorial, but we don't have to do that, because if you go to your example patch, if you go to TX delay and double click on txdelay.maxproj and open the gen folder, and yep, it's in a bit of a mess, but don't worry, all we need here is this little guy here. So let's unlock this, and this is, oh yes, this is my hacky patching with no name on it, but when you open it up you can see this little algorithm, and this is your tap tempo analysis patch. So what we're going to do is we're just going to steal this. So hit Command C. And close this one. Then we're back at the simple delay, Gen DSP. So, and then we're just going to paste this. And what you need to do is to connect the push input that goes into this there. So even for the seasoned Max users, if you haven't played with Gen, loads of these objects looks a bit unfamiliar, but don't worry, we're going to go through each one of them, and I'm going to explain why I use this and how we're using this to analyze the length. And I think it will make things a bit easier to visualize things again. I mean, it's just me. I love visualizing things because I'm not that great with math, so I always need to see things. So let's set out 3 and then plug that in, and then unlock the max patch and then plug that in there. And I think, if I remember it correctly, yes, my range is still from the last episode, so I'm going to bring that back to the usual -1 to 1. Right, so I'm going to go back to what's in there. So first thing first, I'm going to show you what's coming in from the push input. So every time I press this, you see a little blip that goes from 1 and then stays there for a little bit and then goes back to 0. And that's basically what the hardware LED button is doing. So when the button is pressed on, it transmits the value of 1 and it stays 1. And that's how you basically press and hold to go through your OWL preset menus. And then when you let it go, it transmits the value 0. And that's all fine. That's how we designed the hardware, and that's great. However, in the world of Gen, transmitting the value of 1 all the time is a kind of a big issue. It kind of causes quite loads of different problems because it's on this audio rate. It updates that value 1 all the time. It's not just transmitted once, but it transmitted 48,000 times every second, and that's the problem. So the first thing we needed to do is to transmit that value once and then be done with it. And that's what this delta object would do it for you. So let me just plug this one in. And what delta does is it actually analyzes the difference of the value. So when I press this now, what's going to happen is, there you go. So instead of one lengthy blip that goes from 0 to 1, stays there and then comes down, instead what you're going to get is a much sharper blip that goes from value 0 to 1 and then comes back to 0 and then goes down to -1 and comes back, because from the transition of 0 to 1 the difference is 1, but when it comes from 1 to 0 the difference will be -1 because you're coming down from 1 to 0. So that's all good, and that's quite handy because now we only have the value of 1 once. That's good, but it creates a next problem, which is that -1, the negative side of the blip. So we need to filter that out, and luckily Gen actually gives us the exact object that it does it for you, which is your GTEP. And GTEP actually stands for greater than or equal pass. And if you don't input the value, you have a second inlet on the right. But in this case, we already know what value to be filtered out, which is -1. And we want it to pass the value 1. So we just type in value 1. And what's going to happen now is every time I hit the button, there you go, you only get the positive blip. And that's, now we can say every time you hit the button once, it only tells the system, yeah, the button is hit once and not held. So that's all good. And then, so every time you press the button, the value 1 will be transmitted to next object, which is called accum. So every time the value comes in, it sums the previous value that it output, sums it, and then outputs the new value, but it also stores that new value. It accumulates the amount over time. And that basically goes into the counter. So every time counter receives a non-zero value, it actually adds that amount per sample. And what it means is, for example, in OWL, we set the sample rate to 48K. And that means if you input the value 1 to the counter, what's going to happen is it actually counts from 0 to 48,000 in a matter of a second. And what's interesting with the counter is if you input value other than 1, then it actually multiplies the amount. So, for example, if you input value 2, what's going to happen is in a matter of seconds, it will count from 0 to 96,000. So that's all good. So every time value 1 comes out from accum, it will start counting from 0 to 48,000. However, accum being accum, so the first one is good. That's all good. Perfect. But second time you press it, it's going to output the value 2. And that's going to be a problem. And that's where this little feedback loop here comes in handy. So let me clean up this code a little bit so we can see it a little bit better. So this object here is called logic equals. And basically it actually compares the value that comes in to the number that is on here, or if you don't input the numbers, you can actually have the second inlet and then you can input the number there. So the first tap starts counting the length in samples, and then the second tap should stop that counting. And that's what we're trying to do. So, and because it's a logic, what's going to happen is it only transmit, regardless of what value you put on, it only transmit either 0, which is off, or 1, which is on. So because it's equals, so any value that comes into this object, if it's not 2, it always transmit the value 0. And as soon as it receives the value 2, it transmits the value 1. So every time you hit the push button second time, what's going to happen is Accum transmits the value 2. It goes into the logic, and then because it's equal to 2, it transmits the value 1. And then when you hover the mouse on the second inlet, it says non-zero reset. And what it means is every time the Accum objects receive the non-zero value, it actually resets the counting to 0. And the reason why we put the history is because you can't just feed that back, because that's going to create an infinite loop and Max won't be able to handle it. So you need to delay it by 1 sample. And that goes into the counter as well, because every time we hit the second button, we want the counter to reset the count so it can count from 0 again. And then that leaves us with the final object called Latch. And basically, as the name suggests, it actually latches the value. And what we're trying to do, and this is a little bit of tricky bit. So Latch always stores the very last value. So what we need to do, and then on the second inlet, whenever it receives the non-zero value, it actually purges the final value it stores to the output. So what we need to do is we want the Latch to purge the final count before it receives the non-zero value, so it resets to empty. So that's why this history comes in handy again, because this one delays that non-zero value that resets the counter and Accum, but we're not delaying that value that comes into Latch. So what's going to happen is, so Accum triggers the counter, and then on the second push, before it resets the counter, so the counter transmits 0, it actually tells Latch to purge the actual maximum number it counted, and then the counter and Accum reset to 0, and then you can start over again. So before we do this, I'm just going to add number tilde, because I don't want to change the value of scope again. So every time I hit the first one, it does nothing, but second time it tells me how long in samples it elapsed. So every time nothing, yep, nothing, yep, and then I can make it faster and faster if you want. So yep, this is all working. That's good. So let's go back to the gen patch. So what we need to do is to grab the parameter A input, and since now we know the tempo, we don't need this like a generic delay value. So instead, what I'm going to do is, because I wanted to divide the sample length that we analyzed, so we want to divide, I mean, you can multiply it as well, but I personally like to divide the delay tempo. So as you turn the knob higher, you can get a faster delay time. So, but one thing to be careful is, in a world of DSP, you never ever divide the value with 0. I don't know if you remember your math class, but when you divide something with 0, the answer becomes infinite and it cannot compute the number infinite. So what we need to do is to create a fail-safe system. And the way to do this is, so first of all, we want to offset what's coming in. So this creates the value, instead of going from 0 to 1, what it's going to do is it actually add 0.001. So the value becomes 0.001 to 1.001. And then I'm going to multiply it by 7. And then add this magic object called seal. And seal meaning ceiling. So what it does is it actually truncates the floating value to the nearest maximum integer. So what's going to happen is, so the output of the value here is going to be 0.007 to 7.007. But because it's going through the seal, what's going to happen is the value will be truncated between value 1 and 8. So what you're going to get is a division of your tempo, and that's perfect. So we're going to get rid of this. Remember, you can't have more than 3 audio inputs or outputs on OWL. So let's make divide object. And then what we want to do is to divide the sample value by the value coming into A. And then plug that to slide. Okay, so it's all working. So I'm going to quickly save this and load it onto OWL. And we can play with feeding the clock and have this like a tightly synced delay. So bear with me. Okay. So it is loaded. So I'm just going to take clock from my clock divider. I'm going to make it slower actually, and plug it in, and then play it. So that's the drive. Just going to make it a bit slower. You know, the good old razor. There you go. Now you have a really tightly synced tap delay. Okay, so that's it. Well, thanks for watching. I hope you learned a little bit of more sort of a logic side of Gen rather than just the audio side. If you have any further questions, feel free to give us a shout as usual. We're happy to help. There will be a text version of this tutorial as well that you can download. And we will be back with one more episode on the delay before we move on to next patch. So stay tuned, and don't forget to subscribe, rate, and comment. Thanks for watching. Happy patching and happy wiggling. See you soon. Bye.